Across thousands of years, humans have challenged the impossible. From ancient stone to modern steel reaching the sky.
From the desert floor to the clouds above, the Burj Khalifa rises. Hundreds of workers, cranes, and machines bring each floor to life. Until finally, the tallest building in the world stands complete, gleaming under the sun.
The Burj Khalifa rises from the heart of Dubai. Cranes lifting massive steel beams as the foundation takes shape. Workers carefully assemble steel reinforcement cages, forming the backbone of the world's tallest building. Drilling rigs sink piles deep into the desert soil, anchoring the tower securely. Concrete flows into the foundation, vibrated to perfection, dust rising under the morning sun. Cranes move steel beams precisely, with workers signaling every step to ensure accuracy. Sunlight hits the site as concrete trucks and cranes orchestrate a symphony of construction. Workers secure rebar in deep foundation piles, mud and dust marking their hard work. Cooled concrete is pumped through hoses, monitored by engineers for perfect flow. From above, the coordinated activity reveals the immense scale of the Burj Khalifa base. Close-ups show workers smoothing the concrete, preparing the foundation for the tower above. Steel formwork is assembled, creating the central core that will support the tower's height. Concrete is pumped hundreds of meters upward, filling the core while engineers monitor pressure. Each floor rises systematically, cranes delivering steel and concrete as workers guide them into place. Bolts are tightened and rebar secured, forming the structure with meticulous precision. Concrete buckets are lifted to upper levels, with workers signaling to ensure safe placement. Temporary scaffolding allows crews to work safely at incredible heights. Multiple floors are under construction simultaneously. Cranes moving material in perfect coordination.
This section is
Concrete
stable at 30
is
degrees.
poured for the Y-shaped
Good.
wings,
Check the next blanket.
reducing wind pressure and enhancing stability. At night, curing blankets ensure the concrete sets without cracking, demonstrating engineering science. Steel formwork rises higher, floors taking shape as the tower begins to dominate the skyline. Reflective glass panels are lifted and installed by cranes, workers guiding each piece with precision. Brackets are adjusted carefully, securing the glass across the tower's facade. Multiple teams install panels on suspended platforms, sunlight reflecting brilliantly off each surface. Cranes deliver heavy panels to midsection floors, workers coordinating placement with hand signals. Installed panels are cleaned and inspected to maintain the tower's sparkling exterior. Evening floodlights illuminate the facade. As crews continue panel installation, bolts and brackets are tightened, holding each panel firmly against wind and weather. Upper sections receive massive panels lifted by cranes, workers guiding them safely. From above, the partially completed facade shows workers moving efficiently along scaffolding. Final panels are secured. Sunlight fades, leaving the glass reflecting the last light of day. Mechanical floors host HVAC systems, piping, and electrical networks critical for the tower's function. Elevator rails are aligned using lasers, ensuring smooth and precise travel. Wide views reveal teams installing
Bring the reins
mechanical
over here.
systems across multiple floors simultaneously. Workers assemble elevator counterweights hundreds of meters above ground. Technicians test elevators, checking alignment and operation to exact tolerances. Fans, pipes, and machinery are mounted, with cranes assisting from outside. Water tanks are lifted into place, demonstrating coordination at extreme heights. Electrical engineers run wiring and conduits, connecting every system safely and efficiently. Fire safety equipment is inspected, harnesses secure, preparing for future occupancy. Multiple crews work in harmony, showing the scale and complexity of mechanical installations. Concrete pours continue on upper floors, with hoses guided carefully by workers. The steel spire is lifted and secured, forming the pinnacle of the tower. Welding teams connect spire sections hundreds of meters above ground, sparks flying safely. Helicopters deliver tools and equipment to spire workers on narrow platforms. Bolts are tightened under nightlights, highlighting the tower against the dark sky. Drone shots reveal workers navigating high floors and spire. Precise coordination, critical. Temporary cranes are dismantled, assisted by smaller cranes to complete the spire safely. Clouds drift below as the top floors and spire near completion, a marvel of engineering. The final steel segments are lowered and secured, completing the tallest spire in the world. Workers finalize the bolts and panels at the spire, marking the end of vertical construction. Safety inspectors walk floors, checking harnesses and scaffolding stability. Emergency evacuation drills are practiced, ensuring readiness for all personnel. Elevator shafts are inspected and aligned, securing smooth and safe operation. Wind sensors are tested to monitor tower stability in extreme conditions. Railings and barriers are installed along upper floors for maximum safety. Construction managers coordinate operations, walkie-talkies and clipboards in hand. Harnesses and tools are checked, ensuring workers' safety across the tower. Multiple crews operate in unison, demonstrating disciplined coordination. Structural reinforcements are inspected and measured with precision tools.
Did you get the readings from
Nighttime safety checks illuminate workers and machinery, maintaining high standards. Robotic window cleaners glide along rails, maintaining a spotless facade. Squeegees and brushes sweep water across panels, sparkling under the sun. Workers inspect glass panels, making minor adjustments for perfect alignment. From afar, the tower's glass facade shines brilliantly, reflecting sunlight and skyline. Exterior lighting fixtures are mounted carefully by crews, ensuring proper placement. Cranes lift finishing materials to mid-floors, supporting teams working on final touches. Brackets and bolts are double-checked, securing panels against wind pressure. High-angle views reveal workers completing exterior finishing along scaffoldings. Evening lights are tested, illuminating platforms as workers move safely. Final panels are secured. Cranes idle, leaving a pristine, completed exterior. Aerial views capture the completed Burj Khalifa. Cranes removed.
Look at the view from up here.
Last workers cleaning the site. Crowds gather at the base.
It is magnificent.
Barriers and signage in place for the grand opening. Sunset reflects on the glass facade, while inspectors conduct final perfection checks. Drone orbits show the full height, cityscape below, and desert beyond. Finally, Burj Khalifa stands complete. Workers celebrate, lights illuminating the tower at dusk. A triumph of human ingenuity.
In the heart of 19th century Paris, the city buzzed with innovation and ambition, and along the Seine, plans were underway for a structure that would challenge the limits of engineering, the Eiffel Tower. Horse-drawn carriages clattered over cobblestone streets as Parisians went about their daily lives, unaware that a monumental creation would soon rise to inspire awe for generations. Gustave Eiffel, a visionary engineer, meticulously studied every detail of his plan, envisioning a tower of iron that balanced daring design with scientific precision. From maps and sketches, the location for the tower was chosen on the Champ de Mars, with every angle and foundation carefully considered for resilience. Between 1887 and 1889, iron, labor, and ingenuity converged to turn this visionary blueprint into reality, marking a remarkable journey in engineering history. The blueprints revealed a lattice of iron unlike anything ever built, demonstrating that strength and elegance could coexist harmoniously. Mathematical calculations analyzed wind resistance, load distribution, and structural integrity, proving that engineering could be both art and science. A skeletal 3D model emerged in imagination before the first beam was lifted, promising a structure that was both graceful and resilient. Each of the 18,038 iron pieces had a precise place, and over 2.5 million rivets would eventually hold the Eiffel Tower together. Eiffel collaborated closely with his engineers, guiding them through countless challenges with experience, intuition, and scientific rigor. From sketches to 3D models, the vision became clearer each day, balancing aesthetics with structural soundness. At Champ de Mars, workers began clearing the site, preparing the ground for the iron giant that would dominate the skyline. Wooden scaffolding and platforms were erected to support the first iron pillars, each carefully positioned for stability. Excavation and concrete footings were laid, ensuring the tower could bear its immense weight for centuries. Cutaway views reveal a hidden network of underground supports and iron reinforcements, illustrating meticulous planning. Surveyors measured and remeasured every alignment, knowing that even a small error could jeopardize the tower's integrity. The first iron pillars were lifted onto their foundations, cranes and pulleys moving in perfect coordination with human labor. The tower's legs rose, scaffolding supporting them, while workers hammered rivets with precision, gradually shaping the iron skeleton. Riveting was perilous work, as sparks flew and each rivet became a critical component of the enduring structure. Over 2.5 million rivets would hold the Eiffel Tower together, symbolizing meticulous labor and scientific design. Crossbeams connected the legs, forming a lattice that distributed weight efficiently while creating architectural beauty. Alignment was constantly checked, as even a minor misalignment at such height could have enormous consequences. From base to rising legs, the Eiffel Tower began to dominate the skyline, a testament to audacious engineering. Wind analysis showed that the lattice structure reduced resistance dramatically, blending applied physics with architectural elegance. Workers climbed scaffolding high above Paris, tools in hand, facing immense risks to assemble the growing tower. Cranes lifted massive iron beams to upper levels, each movement precise, as the structure stretched skyward. Rivets were heated and hammered in rhythmic succession, echoing the human effort shaping metal into art. Workers relied on basic safety gear, yet their courage ensured steady progress at every level of construction. Time-lapse imagery shows the tower's legs rising steadily, transforming a vision into a soaring iron monument. The Eiffel Tower became the first iron tower of its scale, a marvel proving that science and ambition could achieve the impossible. The first observation platform rose, providing both stability and a glimpse of the height that the tower would reach. Stairs connecting the platforms were installed meticulously, balancing practicality and safety for future visitors. From above, the lattice of platforms revealed a geometric marvel where beauty and precision coexisted. Cranes lifted upper iron beams, guided by workers, as the skeleton climbed ever higher toward the sky. Engineers checked every joint, understanding that stability depended on meticulous care at each connection. At 150 meters, the Eiffel Tower dwarfed all surrounding buildings, transforming the cityscape and inspiring awe. From sweeping wide shots, the partially completed tower dominated the skyline, showcasing the brilliance of applied engineering. The summit presented the final challenge, with workers maneuvering massive iron pieces into place under precise coordination. Decorative ironwork was installed at the top, contributing to both aesthetic elegance and structural strength. Elevator machinery was carefully fitted, blending innovative technology with practical access to the upper levels. Summit alignment was verified meticulously, ensuring the top perfectly matched the base, reflecting engineering precision. Cranes lifted the final pieces, completing the iron lattice and transforming vision into a soaring reality. Animated sweeping views reveal the fully assembled Eiffel Tower, every rivet and beam symbolizing human ingenuity. Upon completion, it became the tallest man-made structure in the world, a symbol of progress and technical mastery. Workers celebrated, their courage and skill immortalized in the iron giant that now proudly overlooked Paris. On March 31st, 1889, the tower officially opened as flags waved and crowds marveled at this unprecedented achievement. Visitors ascended stairs and elevators, experiencing views never before imagined, captivated by the tower's grandeur. Comparisons of Paris before and after the tower highlight its transformative impact on the skyline and architecture. Today, the Eiffel Tower remains both a historic monument and a modern icon, admired for its beauty and ingenuity. As the sun sets behind the Eiffel Tower, it glows like a beacon of innovation, a lasting testament to vision, courage, and scientific mastery.
For over 4,500 years, the Great Pyramid of Giza has stood as the ultimate testament to human ingenuity and mystery. How did the ancient Egyptians build this monumental wonder? Step into history and witness the secrets of an impossible...
The story of the Great Pyramid of Giza begins more than 45 centuries ago, when the ancient Egyptians set out to build a monument unlike anything the world had ever seen. It was a project that would stretch human ingenuity to its limits. And
together! Right! That's it! Keep the line! One stride! Stones move! We move!
redefine what a civilization could achieve. Before a single stone was moved, skilled surveyors walked across the Giza plateau, carefully measuring the landscape. With ropes, wooden stakes, and simple geometry, they leveled the desert floor to prepare a perfect platform in which the entire pyramid would stand for thousands of years. In nearby quarries, teams of stonecutters carved massive limestone blocks from the earth, working day and night with copper chisels, pounding stones, and incredible patience. Every strike shaped the foundation of a monument destined to survive empires. Thousands of workers dragged heavy limestone blocks across the desert on wooden sledges.
Keep it tight. Hey! Race the sled. Ready the ramp. Push off.
Wind's in our favor, Captain.
Then we sail straight to the temple.
Pouring water on the sand to reduce friction. This simple technique transformed an impossible task into a coordinated feat of human strength and engineering. Craftsmen spent countless hours smoothing and adjusting each stone so that it would fit perfectly with its neighbors. The Great Pyramid demanded precision that rivaled modern construction. Yet, it was achieved with tools no more advanced than copper and wood surveyors, marked out the pyramid's footprint using astonishingly accurate geometry. Its base was aligned almost perfectly with true north, a level of precision that continues to astonish engineers and scientists. Today, workers began laying the first layers of limestone, carefully adjusting each block until the foundation was strong enough to support millions of tons of stone. Every joint and seam was designed to bear unimaginable weight.
way! Dust kicking up, eyes sharp.
Drive it, nearly there.
Platform in sight.
Sleds on, brace!
Hold set.
That's it. Good work.
As the base grew, more teams carved smoother limestone to be used as the outer casing. These bright white stones were polished so finely that the pyramid would one day shine like a star in the desert sun. Far to the south, in Aswan, enormous granite beams were cut from the mountains and transported hundreds of kilometers along the Nile. These stones, some weighing more than 50 tons, were destined for the heart of the pyramid. When the granite arrived in Giza, workers transferred the blocks onto wooden sledges and dragged them across the desert. The journey required teamwork, coordination, and sheer physical endurance. As the pyramid rose, engineers expanded the construction ramps, allowing stones to be hauled upward with teams of men pulling in unison. Overseers shouted commands, keeping the rhythm steady as each block climbed higher. The ramp system grew more complex with every layer, a constantly evolving structure designed to keep pace with the rising monument. Without cranes or iron tools, ramps were the lifeline of the project. Surveyors checked the alignment of each new course of stone. Even a slight error could twist the pyramid off its axis, so constant measurement ensured that the structure remained perfectly symmetrical. Cornerstones were placed with unbelievable accuracy, anchoring the geometry of the pyramid. These stones acted like the edges of a giant three-dimensional blueprint. Polishing teams prepared the gleaming white casing stones, shaping them with meticulous care. When the pyramid was complete, its outer surface would reflect sunlight so intensely that it could be seen from miles away. Inside the structure, workers built the king's chamber using enormous granite blocks. Raising those beams into position is considered one of the most impressive engineering achievements in human history. Architects supervised every detail inside the pyramid, calculating weight distribution, angling passageways, and designing chambers that would remain intact for eternity. Long passageways were carved through the stone, leading deep into the internal chambers. These corridors were straight to an accuracy of centimeters, astonishing for workers using only simple tools. Ventilation shafts were cut with extreme precision, connecting the inner chambers to the sky. Their true purpose remains a mystery, inspiring endless theories among scholars. Outside, more limestone blocks continued to arrive. Workers organized assembly lines to move the stones upward, passing them from team to team along the expanding ramps. As the pyramid grew taller, ramps were extended and reinforced, climbing upward in a massive spiral. Each day, hundreds of stones traveled the ramps like a continuous river of rock. Surveyors checked the angle of the pyramid's slope, ensuring that all sides rose at the same perfect inclination. This angle gave the monument both its shape and its structural strength. Casing stones were shaped into exact triangles, designed to meet seamlessly along the edges. A finished pyramid would have looked more like a smooth geometric jewel than the stepped structure we see today. Inside the chambers, workers built corbelled ceilings by placing stones slightly forward with each layer. This created arch-like structures capable of supporting the colossal weight above. Survey teams repeatedly measured all four sides of the pyramid's base, marveling at how perfectly their work aligned with the original design. Their accuracy continues to be studied by modern engineers. More granite beams were hauled upward, each requiring immense effort. Teams worked in perfect coordination, using levers, pulleys, and human muscle to lift the stones into the king's chamber ramp workers constantly rebuilt and smoothed the rising pathways. Without this maintenance, construction would have slowed to a crawl under the weight of millions of stones. The outer casing stones were polished until they shone like glass, creating a surface so bright that ancient writers said the pyramid glowed with sunlight. Workers carried baskets of mortar up the ramps, supplying the materials needed to lock each stone securely in place. Every block was adjusted with remarkable patience. Inside the passages, final measurements were carved to maintain the perfect angles required by the architects. Even the narrowest corridors were designed with symbolic and structural meaning. As the structure neared its final height, ramps grew steeper and narrower. Workers moved slower, but maintained the same rhythm, determined to reach the summit. Skilled artisans placed the upper cornerstones, continuing the laser-like precision that defined the entire construction. Lever systems were used more frequently at higher levels, allowing workers to lift stones with carefully balanced counterweights. Outer casing stones near the top were shaped and polished, creating a smooth slope that would reflect golden sunlight across the desert. Inside the Great Pyramid of Giza, workers inspected the king's chamber, adjusting and smoothing the granite to ensure flawless structural stability. Ventilation shafts were refined, carved straight through limestone toward the stars. Some believe these shafts aligned with specific constellations worshipped by the Egyptians. Ramp crews strengthened the pathways each morning, ensuring sledges could travel safely to the upper levels, even under heavy loads. Huge limestone blocks continued their journey toward the summit, carried by teams of workers who had become experts in coordination and timing. Inside the pyramid, final blocks were positioned to complete the internal corridor system, sealing areas meant to remain untouched forever. The capstones were shaped with extraordinary care, designed to crown the top of the pyramid. Ancient texts suggest they may once have been covered in gold. Polishing crews worked on the uppermost casing stones, ensuring that even the highest layers gleamed brightly in the sun. As the apex neared completion, workers placed the final stones with ceremonial precision, completing the most famous silhouette in human history. Surveyors took one final set of measurements, confirming that the pyramid's geometry was executed with stunning accuracy, rarely matched even today. Builders locked granite beams into high chambers, forming durable ceilings capable of holding thousands of tons of stone. Ramps were expanded to reach the very peak of the Great Pyramid of Giza, marking the last and most challenging stage of construction. The final apex block was lifted into place, symbolizing the completion of decades of labor and devotion by tens of thousands of workers. Polishers finished the top stones, creating a radiant point that would shine across the desert for centuries. Overseers inspected every chamber, corridor, and outer surface, ensuring the entire monument met the precise vision of the royal architects. Scaffolding was removed layer by layer, revealing the smooth, polished surface of the finished pyramid. Workers cleared debris from the site, shaping the environment around the pyramid into ceremonial courtyards and pathways. Artisans decorated nearby temples, carving inscriptions that celebrated the pharaoh and honored the gods who guided the construction. Final inspections confirmed the structural integrity of all internal rooms, ensuring the monument could withstand earthquakes and centuries of storms. Granite beams inside the king's chamber were reinforced, creating a chamber designed to last until the end of time. The last workers polished the outer casing stones until the pyramid glowed white under the Egyptian sun, a beacon of light on the horizon. Ramps were dismantled entirely, revealing the true geometric perfection of the Great Pyramid of Giza for the first time. Workers gathered together, gazing at the finished monument towering above them, knowing they had created something eternal. As the sun set across the desert, the pyramid cast long golden shadows, transforming the landscape into a scene of timeless majesty. Desert winds whispered along the polished limestone, carrying the first stories and legends of the monument that would become the last surviving ancient wonder travelers from distant lands saw the finished Great Pyramid of Giza and stood in awe, unable to comprehend how humans built such an extraordinary structure. Temples, causeways, and smaller pyramids completed the majestic complex, turning Giza into a sacred city of stone. Inside the passages, faint beams of sunlight revealed the silent precision of the chambers deep within the pyramid's heart. From the apex to the base, the Great Pyramid of Giza stood as a flawless expression of mathematics, astronomy, engineering, and human ambition. In the distance, the Nile River flowed steadily, reminding visitors that without its waters, not a single stone could have reached this sacred plateau. And as centuries passed, the Great Pyramid of Giza endured through wars, storms, and empires, standing as the greatest testament to human ingenuity ever created.